Hello once again, viewers. This is Gaurav Gupta bringing you Quest. Quest, as you know, is an inter-school weekly science quiz program aimed more at imparting education rather than being merely a competition. This is a joint production between Doordarshan Kendra Kolkata and the National Council of Science Museums, which is represented by its director headquarters, Dr. Jayantos Thanapathy. Please welcome Dr. Thanapathy. Dr. Thanapathy?
Yes.
Are you ready to show us?
Oh, yes.
How
many experiments to show?
Wonderful. Now, before we proceed in this show, we are going to introduce the teams to you. On my right is the 𝐶𝐸 team, and the 𝐶𝐸 team are the boys from Ramakrishna Mission, Narendrapur. You are?
Hi, my name is 𝐶𝐞𝐦𝐨𝐧. I'm from Narendrapur Residential College.
Hi, I'm Shubha Banerjee. I'm from Narendrapur Residential College.
Hello, I'm Dipra Bhattacharya.
Well, welcome to the show. And on my left are the boys from St. Lawrence High School. That's the C.V. Raman team. You are?
We are from St. Lawrence High School, and I am Indranil Banerjee.
I am Abhijit Raha, and I am from St. Lawrence High School.
I am Sudip Chengupta from St. Lawrence High School.
Well, gentlemen, we can wish you happy quizzing and lots of luck. Without wasting any further time, let's proceed to the first question. So now the first question is for the 𝐶𝐸 team. Let me explain the rules of this quiz to you. In the first part of this quiz, we're going to ask 4 direct questions. 20 points if you get it right on your direct, and 10 on passes. You have approximately 15 seconds to answer the question, at the end of which it will pass to your rival team. If that team doesn't get it right, then we have an audience here. So audience, please be ready and listen carefully to every question as it is asked by Dr. Thanapathy. And in the second part of the quiz, we have the 2 last questions which will be on the buzzer. Plus 20 if you get it right, minus 5, remember, if you get it wrong. The buzzer questions will not go to the rival team. They will go straight into the audience. So if we are ready, we'll move to the first question of this quiz, which goes to the team 𝐶𝐸.
In this experimental setup, I have kept 2 coils of wire suspended in front of 2 magnets. And these coils are connected together electrically, but they are not connected mechanically. If I oscillate one of these coils in front of the magnet, if I oscillate one of these coils in front of the magnet, the other coil starts oscillating, and it will go vice versa if I oscillate the other coil. The question is, there is no electric source here. Then how one coil oscillating in front of a magnet can oscillate the other coil, and they are also not connected mechanically? This is the question.
The coil is made of copper,
Coil is made of copper.
so there should be electromagnetic induction.
Okay, then after that,
And
There's a magnetic field.
where?
From
In front of
opposite
the
poles.
first coil,
Yeah.
right?
And this induces an electric field in
Okay.
the wire,
In the wire.
which causes that other wire, that coil
Yes.
there, there an electric field is also created. Thus,
Okay.
and this causes, and the interaction between the magnetic field and the electric field
of the second
causes
wire
the second
causes a-
coil to oscillate.
Interaction between the magnetic field and electric field in the other coil? You are very near to the correct answer. Okay, I accept your answer. This is correct.
20 points 𝐶𝐸. Dr. Thanapathy?
This is happening because of electromagnetic induction, as you have said. Okay, I accept your answer that this is happening because of electromagnetic induction. Now let me tell you very clearly what is really happening between these 2 coils. You know, whenever there is a relative motion between a conductor and a magnet, electricity will be generated in the conductor. And what is happening here, when I oscillated the conductor in front of the magnet, electricity is produced in the coil. This is because of electromagnetic induction. I have told you that the coils are connected electrically. So, the electricity produced in this coil is transformed. So, the electricity produced in this coil is transmitted to the other coil. And any conductor which carries electricity behaves like a magnet. So, the second coil also becomes a magnet. It produces magnetic field, and that magnetic field interacts with the magnet which is kept in front of it. So, the oscillation takes place.
Well, good answer there then, J.C. Bose team. You pick up 20 points. Let's have a big round of applause for them. And now, the next question is for the C.V. Raman team. Welcome back, viewers. You are watching Quest, an inter-school science quiz, which has been a joint collaboration between Doordarshan Kendra Kolkata and the National Council of Science Museums. The next question for the C.V. Raman team, who are yet to open their account. Here we go.
I have two containers here. Each of them are having water in it. And these two are connected by a pipe which is also filled with water. You know what is this? This is siphon, but that's not the question. You see, water level in both the containers are same, and they're under the same air pressure. If I lift one container, then water will flow from the container which is at higher level to the container which is at lower level. That also you know, this is because of siphon action. But the same air pressure is acting on the surface of both the liquids. Then why the water flows from the left hand side container to the right hand side container?
Well, the pressure acting on the water surface,
Yes.
we have to calculate it as P, which is the atmospheric pressure,
Okay.
minus H rho g, where H is the height from the base.
Okay.
So, in this case, H1, if you consider this H1 and that H2,
Right.
H1 is greater than H2, right? So, P minus H1 rho g will give a lesser value than P1 into H2, P minus H2 rho g. So, the pressure here is, pressure there is less than the pressure over here, so the water will flow.
Okay, tell me, suppose at this point, the water is flowing from the left hand side to the right hand side.
Yes.
You said the pressure of the water H rho g,
P minus H rho g, where
P minus H rho g.
atmospheric pressure.
Okay, your answer is correct, right? But I will explain you little clearly. See, both the water are getting same air pressure, which is P. But above this liquid, there is one water column. So, the water column above the left hand side container is less than the water column which is there on the right hand side container. So, as you said, P minus H rho g will be more in this side than P minus H rho g which is acting on the right hand side. So, that is why there is a flow of water. So, your answer is correct, but it was not very clear.
Well done, C.V. Raman team. You pick up 20 points. In the same manner that water found its own level, so have your scores. You've drawn level with the team J.C. Bose. Both your scores now read 20 points each. And now we'll go into the next question. We enter the third question of Quest. Now this question is for the J.C. Bose team, and not before I tell you that both the teams are tied level at 20 points each. Yes, Dr. Sanapati.
You find at the center of the water there is a candle which has been lighted. You have to tell me what will happen after 10 minutes to this lighted candle. That is the question.
It's this.
𝐺𝐶 team, it's your question.
Will it glow or will it not after 10 minutes?
The flame will go out. The flame will go out.
The flame will go out. It will not glow. Okay. I will not give any marks or any answer right now. We'll wait. We'll come back after 10 minutes and see.
Does this question pass to the C.V. Raman team?
Oh, yes.
It does. He has not given any answer.
It will continue.
to glow.
It will continue to glow. Why?
Because the air cover remains surrounding the flame. I mean the cotton thread on which the flame is glowing.
Okay.
So even when the water, even when the candle submerges due
Yes.
to the melting, that cover remains, which gives
Right.
the necessary oxygen. I mean, what
You mean the candle
will glow?
will glow, go down?
Will glow? No,
Candle will glow.
candle will continue glowing. Yes.
Okay. So I'm not saying whether you are right or 𝐺𝐶 Bose team is right. We'll see what happens after 10 minutes and then we'll award the marks.
So in this case, we will wait for the results before we get the right answer. Somewhat like the third umpire here. We'll move on to the next question. So no change in scores here. And the next question is for the C.V. Raman team, which is on our left.
I have sodium sulfate in my left hand and barium chloride in my right hand. I'm adding barium chloride to sodium sulfate. You get white precipitate. What is this compound?
Barium sulfate.
Barium sulfate. And why you get precipitate?
It's insoluble in water. Barium sulfate is insoluble in water.
Because this is insoluble in water. Okay, that's the right answer.
I don't know. This is
No more.
Well, picking up 20 points there and moving on to 40 points are the C.V. Raman team. But the fate of the third question is yet to be decided, and we'll go now into the next question, which is on the buzzer. Moving on to the fifth question of Quest. This question is on the buzzer. As I've already explained earlier, plus 20 if you get it right, minus 5 if you get it wrong.
I have two beakers here, and in one beaker I have water, plain water. I'm dropping 2 naphthalene balls in it. It settles at the bottom. Now in the other beaker, I'm pouring soda water. And I'm releasing 2 naphthalene balls here, and let us see what happens. The naphthalene balls go up.
They have pressed the buzzer, Dr. Stanapati. So I think 𝐺𝐶 Bose, you have to give us an answer.
And it goes down also. So tell me why this is happening.
Soda water contains water. Carbon dioxide is dissolved in water.
Okay.
So it has a higher buoyant force than the naphthalene, than the buoyant force of the naphthalene dissolved in water. So it goes up, the naphthalene balls.
Okay, that's the answer. Can you tell me little clearly?
Yeah, the effervescence of carbon dioxide pushes the naphthalene.
Okay, I'll give you marks. I'll give you marks.
Okay, great answer there, 𝐺𝐶 Bose. You pick up another 20 points. And let's have a more detailed explanation from Dr. Sthanapathy.
You know Archimedes' principle. What does it say? That when you immerse an object in a liquid, it gets upward thrust, which is equal to the liquid the object has displaced. In case of water, when you drop the naphthalene ball, it gets upward thrust, but the weight of the naphthalene ball is more than the weight of the displaced water. In this case, where you have soda water, the bubbles are around the naphthalene ball, so its effective volume is increased. And because of increase in its effective volume, it becomes lighter. The thrust it gets from the soda water is more than the weight of the naphthalene ball. So it floats. Now it comes up, and after coming up at the top level, the bubbles go. So it becomes again heavy and it goes down. So Archimedes' principle is applied here.
Great answer there then, J.C. Bose. When he discovered it, he said Eureka, and I'm sure you must be saying the same because you knew it. And we now go into the last question of today's quiz. Welcome back, viewers. You're watching Quest, the inter-school science quiz for students studying between classes 9 and 12. We are still waiting for the results of the burning candle, and until we have the results of that, we won't know which team scored what. But as you would remember, scores are tied, and both teams, that's the J.C. Bose team as well as the C.V. Raman team, have got 40 points each. The last question also on the buzzer.
I need a volunteer for this.
We need a volunteer. Do we have any volunteers here? Well, I see a lot of volunteers. Why don't you come up? Your name?
Varun Moore,
And which school are you from, Varun?
Birla High.
Are you ready to be experimented upon?
Yeah.
Nervous?
No, not at all.
Not nervous. Okay, let's see what you can do.
Okay, come here. See, this is an object which we normally don't see. You have to balance this on the stick like a juggler. Are you ready to do that?
I'll try.
Okay. You can do anything you want with this. No? Okay,
Okay.
I'll tell you how to do this.
They have an answer, Dr. Sthanapathy, so let's see what the C.V. Raman team has to say.
If you rotate the spindle
Yes.
about the pinpoint on that rod at
Okay.
a very high angular velocity, then it will not fall because of gyration. So when it is in rotating motion,
Yes.
it cannot fall off from the rod.
Okay, that's the right answer. Very good.
And now, Dr. Sthanapathy is now going to get into the jugglery act.
Okay, let's see. If I spin it very fast, and you know, I can easily move like this,
Let's have a big hand for
just
him.
like a juggler.
Well done, sir.
Very good. Very good answer. Now let me explain you what he has said little clearly. A rotating object has angular momentum, and angular momentum is conserved in this case. And you know, angular momentum is a vector quantity, so it has magnitude as well as direction. So while spinning, the spin will be maintained as well as the direction of its spinning will also be maintained. So it doesn't fall, and there is no credit in juggling the spinning top. It remains as it is without any special effort.
Would you mean even I could do it, Doctor?
Oh yes.
Well, I don't think I'm going to try on this show. 20 points, C.V. Raman team, well done. You now move on to 60, while we still await the results of the burning candle. Now we are back to the question of the burning candle. 𝐺𝐶-BOSE team said it will be extinguished, whereas C.V. Raman team said it will remain on, but they could not give the right explanation as to why it would not go out. So now we are going to go into the audience and ask for volunteers for answers. Anybody in the audience with an answer? Yes, please come. What's your name?
Sir, Ravikant Kesana.
Yes, Avikant, why don't you face the camera and tell us?
Sir, the candle would not go out because the heat produced by the burning of the flame would not be able to melt the wax because the heat would be absorbed by the water. So the column would remain the same and the candle would continue to glow.
Okay, that's absolutely right answer.
Wonderful
Very good.
answer. Well done, Avikant. You can go back. Would you like to explain that further, Doctor?
I think he has explained very clearly, because of water, the wax is not melting, it is cooling down. So the flame continues to glow. That's the right answer.
Well, so very much like the flame of knowledge, this candle is never going to go out. At the end of Quest, which is a science quiz for young minds, we find the final scores. C.V. Raman team is on 60 and 𝐺𝐶-BOSE team is on 40. We thank you for joining us for this week's edition, and I'm sure you will be back again because we'll be happy to see you next week at the same time. Goodbye. Thank you.